Welcome to Programming in Modern C++. We are in week 5 and I am going to discuss module 21. In the last week, we took a look at different features of classes and member functions across C++, across different varieties. We understood what is a friend function, what is a static function, and using the friend function particularly, we introduced operator overloading in depth in a user defined type, and we also discussed about managing lexical scopes in C++ using namespace. From this module, we are starting on a very key area of C++. In terms of object oriented analysis and design, we have already seen that one or the first core objective or principle of OOAD, which is encapsulation, has been achieved by using different access specifiers, get set idioms, and how to selectively break that using friend and so on. From this module, we start working on the second very key principle of OOAD, which is about specialization generalization hierarchy or is-a relationship, and we will build up on these to get into the final target of having polymorphic behavior. So, in this introductory module, we will first talk about what is a relationship in OOAD, because all of you may not be aware of that, and then discuss through examples as to how it is to be achieved in C++, where it is called an inheritance. So, first talking about is a relationship, I am writing it here like this, is a. You can, many places people like it also like this, which means is a, right. So, you say car is a vehicle. So, that is the point from where this particular name comes, that when I have one object which is either a generalization or specialization of another. For example, vehicle is a generalization of car, I mean something which allows us to move around, but so does so many other vehicles like train, like bus and so on. And car is a specialization of vehicle because it has the behavior of a vehicle and it may have something extra which not all vehicles may actually have. OOAD models this as is a relationship, and in C++, we model this by inheritance of classes. So, let us start with a couple of examples to understand the is a relationship better. So, think about flowers. You know, we all know flowers, and flowers have certain properties like they have fragrance, usually I am saying. They have petals, petals may have different kinds of colors and so on. Then if we talk about rose, we know rose is a particular type of flower, right. It could be, there are several other types of flowers as well. So, rose has the properties of the flower, but it has an additional property which is the rosy fragrance, right. Now, if I talk about say another flower, say jasmine, it is also a flower. It has fragrance, it has petals and so on. Now, but the fragrance of jasmine is different from the fragrance of rose. So, rose is characterized by its rosy fragrance. It may be characterized additionally by its color, number of petals, arrangement of petals and so on, but we are just keeping it simple, working on the fragrance and so on. So, if in this situation, then we say that rose is a specialization of flower. So, rose has the properties which a flower will always have, but may be distinct from another flower like jasmine. And flower is a generalization of rose, right. So, it talks about certain generic properties of rose, but does not may not address all the properties of rose. Now, further we can say that most of us are, by rose we identify or we think of a red flower. We say it is a red rose, though there are roses available which are yellow in color or white in color, but less frequently though. So, we will say that red rose is a rose which has properties of the rose including the rosy fragrance, but it has an additional property that its petals are red necessarily. Right. So, again rose is a generalization of red rose, and red rose is a specialization of rose. Right. So, that is how it goes, and we diagrammatically often represent this to make the understanding easier. So, this is, we draw a directed arrow from the specialized object or the specialized concept to the generalized concept, an arrow which has a open head, right. It is an arrow like this, not like this, it is an arrow like this, which means it is a easier relationship. So, whatever we have written here, this specialization generalization can be just captured in this diagram. Rose is a rose, rose is a flower, right. So, that is the basic understanding. Now, there could be other kinds of such specialization generalization. Let us think of vehicle, we are talking about car, and we say two wheeler is a vehicle, three wheeler is a vehicle, right. Both of them are vehicle, they are means of moving around, four wheeler is a vehicle and so on. So, the diagrams could also look something like this, where multiple concepts are specializations of one generic concept, generalized concept. Then we can have something very commonly as manager is a employee. Companies have managers and they have employees, but the manager herself is also an employee, right. So, this is captured in this kind of a easy diagram. So, these are different, there could be hundreds and hundreds of different types of easy relationships that can happen. So, with this example, let us try to see how we capture these in terms of C++ classes, right. We know every concept in object oriented analysis and design can be represented by a class with its data members, that is the state defining values, and the member functions which basically tell the behavior or the interface of that for that concept. So, following that, when we have manager is a employee like this, we have a class employee, which is a generalized class, and then we define class manager, and this information of is a is captured by this syntax. We put a colon after the specialized class, the manager. We use the keyword public, and this use of the keyword public is different from the use of keyword public as access specifier. We will see what it means in different contexts, but it is, just get it in your mind that if you are going to define a easy relationship, then this keyword is going to be public, and then you specify the name of the generalized concept, generalized class. So, you say that class manager colon public employee means manager is a employee, right. Whatever is generalized is called a base class like here, and whatever is specialized is called a derived class. So, as if The term comes from the fact that as if the properties of the base class or the generalized concept is being derived into the specialized one. So, here you have derived class as manager and the base class as employee. So, that is the terminology that we will continue to use. So, this is called a single inheritance. Single because you just have one level, right. One manager is a specialization is an employee. Right. You can have the two-wheeler, three-wheeler. Two-wheeler is a vehicle, three-wheeler is a vehicle. So, we have a base class or the generalized concept as vehicle, which is what we call a root, because you will soon see that this becomes a tree. Class two-wheeler is public vehicle. So, it is a derived class with base class as vehicle. Similarly, class three-wheeler is public vehicle. So, it is a derived class with base class as vehicle. So, multiple classes can have the same base class. Right. This is known as hybrid inheritance, where many arrows go to the same base class. Right. It is called the hybrid inheritance. So, if we talk about hybrid inheritance, we can visualize this kind of a tree diagram. Then we can have the rose example. So, we know red rose is a flower, right. So, flower is the most generic concept. So, it becomes a base class, it becomes a root. Then we have rose is a flower. So, we say derived class is rose, the base class is flower. And then we say the red rose is a rose. So, now rose becomes the base class and red rose becomes the base class and red rose becomes the derived class. Right. So, you can see that unlike here where the base class is the same, the root, here the base class is not the same, it goes at multiple levels. So, this is known as multi-level inheritance. There are other forms as well, particularly inheritance where a base class, there could be multiple base classes and one derived class which derive from both of them, right. This kind of a diagram. Right. If this happens, then we say it is a multiple inheritance. That is concept wise, that is far more complicated. So, we are going to discuss about it much later. So, I did not talk about it here. So, for now you have single inheritance, hybrid inheritance and multi-level inheritance to start with, which potentially can give rise to a hierarchy. So, let us take another example. We all are now driven by phones, right. Now, over our lifetime, actually you are also experiencing that there are varied kinds of phones that are possible. For example, what we have to start with is a simple landline phone. What we now, earlier we used to call it a telephone, but now since there are so many other types, we call it a landline telephone, BSNL landline connection and so on. So, which has a physical wired connection usually. So, a landline telephone will have very limited features or limited interface behavior. That is, with that you can call, you can answer to a call, and some landline phones, particularly little advanced ones or with a special attachment, can also show you the caller ID. That is, in case of an incoming call, you can see the phone number from where the call has been made, which was not earlier usually available. Now, this call in a landline phone could be either through dials, you all have seen those dials. If you have not physically seen them, then please refer to some Bollywood movies in the 70s, 80s, you will often see that this kind of dialing is. So, you have to rotate the dial. So, the call could be by dialing, or the more recent landline phones have a keyboard. You have keyboard, physical keys using which, so you can have dials or you can have keyboard, but the functionality that the landline phone offers is that you can make a call, you can answer a call, and optionally you may be able to see the caller ID. Now, from that we moved on at least in India in the say middle of 90s, I should say, in terms of mobile phones or cell phones, which can work anywhere, not fixed with a wire. There have been several other types of phones also in between, but mobile phone, and it became very popular with nice Nokia 1100 kind of small phones which everybody used to carry around and so on. So, what can you do with that kind of a phone? You can call, but here you call by keyboard, and normally it shows number. In some landline phones keyboards show number, but many may not show the number also. You can call by number and also by name, that is there is some mechanism which now we know, we call it address book, where I can pick up the name of my friend Shamul, and without keying in the number I can make a call. So, this is a typical behavior of the mobile phone. So, you can again do a call, but that call is little bit more eased, more sophisticated. Certainly, you can answer a call. The caller ID almost certainly is built in. You do not need any other device. If call is coming in, you know what number it is coming from. You have other features, additional interface features, behavior that are provided in the mobile phone, which you did not have in the landline phone. So, you can redial a number, something you got a call, you missed it, you can redial a number, or you had called earlier, you can dial it again, you can redial. You can set the ringtone. This also has ringtone, landline also has ringtone, but typically a fixed one, very kind of loud, irritating kind of ringtone, but here you can have different ringtones. You can add contacts, you can make your list of contacts, what we say is the address book. You can add contacts obviously at least by number, along with that you can also have names. So, this is what a typical mobile phone or cell phone that we migrated into. Then came the late 90s and early 2000, when we started having smartphones, and into this millennium the smartphones kind of became the default, where you could call using the touch screen. You do not have keyboard, key pressing boards. If you have a keyboard, that also is kind of virtual. It is just a touch screen where you can touch, or you can pick up a number by other means. You can call by number, by name, which you could do in a mobile phone also, but it gets easier. You can obviously answer, you can have caller ID, you can do redial, you can do set ringtone. All of these which you could do in the mobile phone, you can also do it in the smartphone, but you do it in a somewhat different way. You set the contact in a different way. You make the call in a different way. For example, you can call by number, name, but you can also call by photo, right. Often mobile smartphones have a favorites list shown, where you can see photos of your contacts, and you can pick up a photo and say call this person. Similarly, you can call by photo. So, the basic idea that I am trying to drive in is, if we take these three types of concepts of landline phone, mobile phone and smartphone, they have a lot of overlap in the functionality, but with the factor that mobile phone can do almost everything that a landline phone can do. A smartphone can do almost everything that a mobile phone can do, but as you move from landline phone to mobile phone, you have additional behavior. As you move from mobile phone to smartphone, you have additional behavior. There will be several others which I have not mentioned here. For example, I am not talking about the non-phone functionality of smartphones, like you can go to YouTube, and you can run apps and go to YouTube and all that. I am not talking about those, but I just want to stay focused in terms of the basic purpose of the phone, which is to make calls and to receive calls, right. So, this belongs to a specialization, generalization, hierarchy. So, I can say smartphone is a mobile phone is a landline phone very easily, right. So, this is the different kinds of. So, looking at the real world, you will have to extract these kind of generalization, specialization of concepts between different concept between different classes. So, in a generic form, I say that my generic requirement is, or the situation is, that derived is a base, right. The derived could be anything. It could be manager is an employee, it could be rose is a flower, it could be mobile phone is a landline phone, whatever. So, I am modeling it with this, which you have seen, that I have a base class which I often call the root, and I have a derived class which is public base. Right. The keyword public after the class name denotes inheritance, right, and the name of the base class follow that keyword. So, this is what represents is a relationship, right. That is about the basic semantics of capturing the relationship of generalization specialization in terms of C++ classes. Right. So, let us look at some of the common properties that we will have. So, this is the situation, derived is a base. Now, obviously, so I have two classes now. I have base and I have derived, and they are related to by is a relationship. Right. So, now I know we have only been talking about the interfaces behavior, but we know that there has to be state variables, the data members. So, what happens is there is a notion of inheriting from your base class. Often this is also the alternate terminology that we will keep on using is parent and child. The parent, child inherits everything. So, all data members of the base class becomes data members of the derived class, and the data and the base derived class can add further data members. Similarly, all member class member functions of the base class is inherited by the derived class, that you have them in the derived class as well. You can do certain things like override by redefining it, or you can overload by giving another member function by the same name, but with a different signature. We will come to what these things mean, but all that I am trying to say is in this hierarchy that we are creating for inheritance, the generalized the data members and member functions of the generalized class, the base class, is inherited by the derived class, that even if I do not write anything in the derived class, a derived class object will be having those data members and will be having those member functions. There are access specification restrictions. Derived class cannot access the private data members of the base class as no one else can, but there is something that we will introduce which is called a protected access specifier, the third type beyond public and private, which will give a selective access for the derived class to the members of the base class. We will see that. And then we have different semantic differences in terms of the constructor and destructor. To construct a derived class object, you will have to first construct the base class object, because base class has data members which you inherit, right. So, it has to be constructed, and then you construct the derived class object. Similarly, for destruction, you will have to destroy the base class part of the object, and only then you are ready to destroy the derived class. So, these are the different aspects, that is sharing the data members, sharing member functions, and the sharing is always in this form, that you have base and you have derived. Just get this notion clear, that whatever you have here, you will also have here, whether it is data member or it is member function. but you can add your own in terms of data members, you can add your own in terms of member functions, you can add new member functions also, and you can data members you cannot change, but member functions you can change them by giving a different definition for the member functions that you have derived, or giving a overload to the member function that you have derived, or adding a new member function. So, we will have to see all this behavior. Access specification is critical to decide, So, this protected will give us certain special type of access specification where certain members will be visible to the derived class only. To the external world, they will remain as they will be same as private, they will not be able to access those. To the base class itself, it is like everything is available, so it is like public. But the specific semantics is the derived class will be able to see these members, will be able to access these members, whereas no one else would be able to do that. But for private, the derived class will still have restriction that it will not be able to access the private members, and then we will have a sequencing in the constructor destructor call. So, this is the entire broadly I should not say entire, but the basic semantics of inheritance in C++, which realizes the is-a relationship of object oriented analysis and design. And going forward in the subsequent modules in this week, we will slowly take up these and explain with detailed example as to what do they mean and how to use them. And after 2 modules, we will also take up in module 24, we will take up a little bit of more detailed example, particularly expanding on the generalization specialization of the phones that we have discussed, and we will show you how from the simple idea of landline phone is a generalization of mobile phone, which is a generalization of smartphone. How can you create their entire interface and then subsequently the data members in this kind of a scenario. Thank you very much for your attention. We will meet in the next module.